Okay, geometry. 10.5, page 492. That's your assignments. Now, this one is called symmetry. I'm hoping you all have some basic understanding of what symmetry is. In science, you find out that humans are bilaterally symmetric. If you cut you in half, fold you over, basically matches side to side. Now, my drawings really kind of suck today. I didn't say that. I didn't say it out loud, did I? All right. So, symmetry. There's a couple different kinds of symmetry. One is line symmetry. If I can draw a line somewhere through this thing and fold it over, that's line symmetry. There's no line symmetry on this. Now, the more I redraw this, the worse it gets. Okay, this one here, if I cut it like this and fold it over, it will match. If I cut it, like this, cut it like this and fold it over and match. So there's basically three lines of symmetry, like this. Does that make sense? You can fold it. No, I take it back. Those are not lines of symmetry. I apologize, will not work that way. Nope, 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 nope. So there's no lines of symmetry on that. If I had a, all right, so you guys like these things. Now, if I drew that right, which I didn't, Madeline, don't even criticize me. If you did this here and I did it right, it would have a line of symmetry. It would fold over. That would be one line of symmetry. Okay? Then we also have rotational symmetry. It says a figure exhibits symmetry if there's an isometry besides an identity isometry that maps the figure onto itself. This one here, there's an isometry. I can take it and fold it over. That's a line of symmetry. Okay, this one here, I could rotate it. Do you understand? If I pick it up and click it over here, and pick it up and click it over here, and do it 3 times, X is going to be back on X. Y is Z. First time X will be down here, and then X will be over here, then it'll be back. So this one has rotational symmetry. Okay? It has rotational symmetry. Now, since there's 360 degrees around here, if I do it 3 times, this is 120. 120 degrees of rotation. 120 degrees, 120. So the degree measure of each rotation is 120. Okay, the magnitude of the rotation is 3. Because it takes, I like to say clicks. It takes 3 clicks. 1 click, 2 click, 3 click. It's back on itself. Okay, so let's see. How about this thing right here? Now this has rotational symmetry. It has 3 lines of symmetry. Actually, it does. Sorry. If right here, line of symmetry. Right here, line of symmetry. Right here, line of symmetry. I can fold it over. This one's going to match that one half. So there's 3 lines of symmetry. Excuse me. Okay? And it's since there's 3 clicks to get back, it's also 120 degrees between there. Okay, so it has an order of 3. Order of 3, because it takes 3 times to get there. This has an order, O-R-D-E, order of 3. Okay, now this one here has a line of symmetry, but there's no way to rotate it unless we go all the way around. So this does not have rotational symmetry. This has point symmetry because it's rotation around a point. It's rotation around a point. This one does not have point symmetry or rotational symmetry. Okay? This one does. And its order is 3 because it takes 3 clicks to get back. 120 degrees. 120 degrees. So let's just look at some stuff here. So on 1 through blah, blah, kind of look at that. Number 1, now you got to think this through. There's a number of lines of symmetry. There may be 1, there may be more than 1, there may be none, okay? Then the magnitude and the order of any rotational symmetry. So the magnitude is the number of degrees, and the order is how many moves it takes to get it back where it was to start with, okay? After stopping on top of itself each time. So if you look at number two, how many lines of symmetry are there? Well, there's the straight up and down, there's the straight across. There's also this one and this one. That makes 4 lines of symmetry. Its first time you're going to turn it is 90 degrees, and it's back on top of itself. 90 degrees, 90 degrees, 90 degrees. So it has 4 lines of symmetry. 90 degrees is the magnitude. 4 is the order. 4 is the order of rotational symmetry. And does it have point symmetry? Yes, because the center is what it rotates about. So it's a yes. All right, that's what you're going to do with each one of those. Okay, and the answer doesn't have to be yes to any of them. Okay, over on 14 and 15, I just want you to do what it says. It's not that difficult. Look at it, see what it takes to rotate it, to get it back on itself. Say how far you have to go to get back on itself, and if there's lines of symmetries or point symmetry. Okay, on 16 through 21, you have to draw out what they say, and then again, does it have rotational symmetry? Does it have lines of symmetry? How many degrees? What's the order of symmetry? And on 25, if you have the 0.37, and you're going to, what does it say? You're going to do something. Oh, the axis of symmetry is the x-axis. Okay, so if you have a graph here, and you've got 0.37 here. This is the x, this is the y. This is x, and this is y. This is the line of symmetry, so it's going to go from here down to here. And what are the coordinates? Okay? So there is going to be one answer or more than one answer to those. Okay? Not too difficult, just a lot of drawing, which I know you'll love.